I'm going to walk you through the analytical hierarchical process, which is the AHP tool. It's a very simple tool for making decisions. And the easiest way to describe it is just to walk you through it and describe it as we're going. So I'll show you how to access it and how we make decisions using the AHP framework. So first thing first, it's usually found if you just type AHP calculator, and the one at the top is the most useful link. And you click on that, and this is an online one that lets you be able to access it. And on here, you can select the number of important criteria to be able to add. And the thing about the AHP process that is really cool is how flexible it is to be able to make decisions for a variety of different things. The underlying basis that this works under is taking a weighted average and making it better. And instead of using percentages that you come up with, it helps calculate those percentages to compare different priorities against one another, and then using those priorities to generate those weights, and then you use it for a decision matrix like you would with a weighted average. So to start off with, we're just going to make a very simple decision. I suggest you do this on your screen. So move this video to half your screen and then follow along on your own, because it'll help you actually learn by doing, and you'll be able to understand more of what we're stepping through. But we're going to make a really simple decision about which supplier should I choose. So let's imagine that we have 3 different suppliers that we're really considering, and we want to evaluate what those suppliers could do for our company and which things should we value for that. Suppliers have different characteristics, and if you look at all the different competitive dimensions in the supply chain, it might be quality, innovation, sustainability, reliability, cost, quality. There's a lot of different factors at play. So first of all, we need to know what are the factors we care about. We need to prioritize which ones are we going to really focus on for our decision-making process. And then we'll evaluate the suppliers based on those. So we're just going to, for this, we're going to use a very simple one. We're only going to use 3 characteristics. And we'll simply add quality, innovation, and let's do reliability. And these are 3 different dimensions that we want to decide which ones are going to be more important for us as a company. And depending on what you're trying to achieve as a company, that might be very different. So we'll just do a hypothetical one. Let's imagine that we're competing in a very high-end marketplace where we have customers that care a lot about something, and they're willing to pay quite a bit for that. They might care a lot about quality, they might care a lot about innovation, and they might care a lot about the reliability. So how do we balance those different dimensions against one another when we choose which supplier should we go with? Now, part of it is the product dimensions, and the part of it's what our company is trying to achieve. So reliability especially tends to be what my company needs more than what our customers need. So, but quality and innovation might pay directly to what our customers are trying to achieve. So we'll kind of have to balance that out a little bit. The first thing is, which is going to be more important for this choice, quality or innovation? And we need to decide which one is better. And I think if I have very high-end market customers, I probably want to focus on innovation because they're paying for something novel, something unique, something new. And so maybe that's the space that I'm going to operate. So I'm going to say innovation is going to be slightly more valuable. And this scale over here from 2 to 9 is basically how much more important is that than another one. And it's a multiplying scale. So 9 is 9 times as important. 2 is twice as important. And so for the most part, you're going to be somewhere between 1, 2, 3, and 4. 1 is equal, 2, 3, and 4 are more impactful. But then you get up to 5, 6, 7, 8, 9, and it gets pretty extreme. So those would be only used if your characteristic wasn't really that important and you're comparing something that really shouldn't be in the decision in the first place. So you really want to stay much lower on this. So normally I say between 2 and 5 is a pretty good estimate. So innovation, slightly more important than quality, but quality is still pretty important. And then let's consider between quality and reliability. I'd say quality is quite a bit more reliable because we can manage the supply chain problems as they come up with, but our customers really are going to expect a certain level of quality. So I'm going to select quality, and I'm going to say it's significantly more important. And then we compare innovation and reliability and see which one of these is more important. I think for this one, it's going to be innovation is going to be more important than reliability. And I'm going to say it's even more impactful. And part of this is to make sure that I'm being consistent. So I'm going to go ahead and click calculate, and we have a score here that says consistency ratio of 0.4%. If that's less than 10%, that means my decisions are lined up with each other and they make sense together. So a bad version of this would be if you had something where you said A is bigger than B, and B is bigger than C, and C is bigger than A. We've created a paradox. And if you can solve that paradox, or you can understand that paradox well enough, you might get a Nobel Prize in economics for it, because that's kind of the paradox that Arrow's paradox came from. So Arrow's theorem, if you want to look that up, and that's kind of where that perspective comes into play. But for our cases, we don't want it to have a paradox. We want to make sure it's consistent. Our decision making is logical. So if we had said, oh, reliability is really more important than innovation, we calculate it, it's going to tell us there's an issue with the way you made those decisions, because you said that innovation was more important than quality, and quality is more important than reliability, but now you're saying reliability is more important than innovation. It doesn't make much sense. So if you get an error, it'll tell you like, hey, one of these is wrong, rethink your system. Then the output that's really useful for the HP is down here. It's the decision matrix percentage weights on the left. This on the right is the math that it's using to calculate it. It's basically creating a system of equations, and then it's solving for the different numbers based off of the weights you gave them. And that's the math going in behind how HP is decided. But the primary thing you want to just focus on is what these weights are on the left side: quality, innovation, reliability. What that means is, for the most part, when we make a decision, in this case, innovation should be 58% of the decision weight, quality should be 31%, and reliability should be 11%. So we're going to spend a lot more time thinking about innovation and evaluating that when we compare those decisions against one another. Those weights then join Excel to be able to form part of a decision. So I'll just quickly step you through that as well. Okay, so I've just copied those numbers over into Excel so we can look at what that would look like. These numbers represent how accurate those estimates are. So if those are very high, you might want to consider different assumptions, but for the most part, I'm just going to focus on these three weights. So these are the key criteria that I'm using to make any decision, and these are the weights. And I want to make sure that they add up to 100. So just to confirm, they should add up to 100. This is the rank order, which one's 1, 2, and 3rd in our priority. But then we want to consider those against decisions. So I might have a few decisions that I'm looking at. In this example, we're looking at supplier A, supplier B, and supplier C. And we want to say, how good are those different suppliers across these dimensions? And then we'll make a choice about those suppliers based on that evaluation. So let's start with just looking at quality. So how good is supplier A at quality? Let's say that they had a 6. Well, not a percent. Let's use the number. Yeah, let's say a 6. And let's move that format to make sure all those tend out to be the same. Let's say their innovation was very high. They were high quality, high innovation. But they weren't a very reliable supplier. They struggled with reliability sometimes. Let's say that there's another supplier B that's very, very high quality, very reliable, but they're not very innovative. They deliver the same product, very consistently excellent product, but that might not fit exactly what we're looking for because innovation is such a high percentage of the decision. And then let's look at another supplier, supplier C, which is really just across the board average on all those dimensions. And how would those perform? Based on these weights, we'd want to make sure that we're prioritizing mostly innovation. So if you do a weighted average, sometimes you'll have another line that says, here's the weighted score. You take the number, you times it by the weight, and you get a weighted score. Like that. Oops, wrong. Yeah, so let's give it a couple more decimal places so you can see that it calculated on that one. All right, so 1.85 is 6 times 30%, basically. And then you could do that for all three. And then you can get a sum of those weighted scores. And then that tells me what's the total value of supplier A. All right, so that's what supplier A is offering. It is a score of 7 overall based off of those different weights. That's very useful information, but I don't have to include that if I don't want to, so I can just type some product if I want to instead, and include these values multiplied by these values, and then sum those products and get a score for supplier B. And if I'm going to do some copy pasting, I want to make sure that those are anchored, so hit F4 on each of those variables so that it's anchored, and then I can just copy this formula over and I get another 6. So supplier B and supplier C both scored the same in this example, even though they were very low on their innovation because of how well they performed on quality and reliability. So those are fairly comparable, but supplier A is the winner because they outperform on innovation, which is the highest scoring characteristics. Even more important than the increase in quality or the major increase in reliability for supplier B. So in this case, I'd look at and say supplier A looks to be the best choice. That's how I would use this decision models to be able to take, here's all the different percentages to make that decision. We piece them together by considering supplier A, supplier B, and supplier C, and we get a score of the weighted product based off of the weighted analysis of those different criteria against one another. Now, the cool thing about this is when I'm going through the AHP system, I can do a lot to be able to make it more interesting, more complicated if you want to spend some time digging through it. So for example, we only looked at 3 issues, but if we were looking at 6 different criteria, we can type in all the different competitive dimensions we're focused on for this decision that we're making. And then we can do comparisons from all of these against one another. So let's say that I'll just add a couple of numbers here so we can see what it would look like. This probably won't be very consistent because I'm not thinking through it, but hopefully it'll give us something and then it'll tell us how to improve it. Looks like we weren't very consistent on a couple of things. So if we had made some good decision making, maybe we come out to something here. And it gives you warnings when you're being inconsistent, which we were there. But you can see we get a more complicated rating system here where we have a variety of different characteristics that we're evaluating here. 30% for criteria 1, 15, 18, 17, 9, 10 for criteria 6. So now we have a lot of different criteria that we can consider for making a decision. So we can use that to be able to make a more complicated decision when we had multiple things. The other interesting thing is you can have multiple raters or multiple people evaluate these and then combine those weights in a way. So it can be more of a joint decision making. So that's a little more complicated than I'll go into it. But if you're interested in that, there are some Excel-based ones that let you have multiple evaluators that can do all of the different ranking systems. But for now, this is a really simple, effective tool to be able to make good decision-making for a variety of issues. The biggest part comes down to how do I decide what the key criteria I want to evaluate are, and then how do I compare those against one another. The one thing that I will suggest is when you make this decision, you want to make sure that you're disentangling cost from those decisions at first and paying attention to making sure that your scores are in the right direction. And I'll explain that just by kind of changing the example a little bit. So let me go back to the Excel. So let's say that instead of quality, innovation, and reliability, I was thinking about purchasing a car, for example. Let's think about the characteristics I care about a car. Let's say safety. We can leave innovation because that's a pretty interesting part about a car, and reliability. So actually, we can just leave all 3 of those. Let's just leave quality, innovation, and reliability for a car, right? And let's say that I'm considering between Honda Accord, Toyota Prius, or a Geo Metro, right? Some other car. And then we can evaluate the quality based off of the reports we read about the different qualities of the car. Let's say that, and I'm not sure if these are accurate because I haven't done this, but let's say that we're really interested in this decision, we'd go through and consider quality innovation. Let's say the Honda is a 6, the Toyota is a higher quality, and the Geometry, let's say it's a lower quality, right? For innovation, probably the Prius is more innovative than the Accord, and much more than the Geo. And then the reliability, maybe the Geometry is more reliable, the Prius is less reliable. Maybe it's dependent on how many charging stations you have or the range you need. So that number could shift based off your use case. And then the reliability of the Honda Accord, maybe that's a 6, right? And maybe that depends on your car. Let me just make sure that's calculating correctly. That does that. All right, so then we have this score, and we can see how good these cars are next to each other, right? So we're getting a 4.84, an 8.4, and a 3.27. This is where I want to introduce cost. I want to make sure that cost comes back into the decision here. Let's say that, for example, the Honda Accord that I'm looking at buying costs $20,000. The Toyota Prius costs $40,000, and the Geo Metro costs $10,000. Now I can use that to decide how effective is this valuation, this score. Like I'm getting almost a 5 from the Honda Accord, and I'm paying $20,000. I can get a lot more from the Toyota Prius based off this, but I also have to pay twice as much. So now we can decide, is that upgrade from 5 to a 9 or 5 to an 8, right? Is that worth the extra $20K to me? I'm still including cost in the decision, but now it has a lot more meaning. I see what I'm paying for. I'm paying for an increase from this evaluation by paying this much more. Or I can go the other way and say, okay, well, this one's only 10. Okay. So is that worth going down to a 3.27, right? Or then I can use cost later. So that's when I like to introduce cost. And then the last one, I want to make sure that you're not using reverse coding. So oftentimes someone might include something like cost here. And again, I would pull it out. But if you did, you'd want to make sure you didn't have this reverse coded. And if you said, oh, the Toyota Prius, well, that has the highest cost. So that's a 10. And the Honda Accord has a low cost. So that's a 5. And the Geometry has the lowest cost as a 2. It reverse codes those. So you have to be really careful that you don't include the backwards numbers here. If a high number here is good for the decision, because a high number here is good. So you want to make sure that if you have something like that, you want to make it very specific to make it reversed. Right? Higher costs are bad. It happens with things like risk. Higher risk is bad. Right? Higher failure rates are bad. So you want to make sure that either you note that it's reverse coded or you change risk to safety or reliability to make it clearly lined up with the way you should interpret the data and make sure you're putting the codes correctly. That's how you use AHP. It's a very effective tool. I've used it for a lot of really important decision making. So I suggest you use it if you're doing something, and it's a very simple tool to really come up with better weights and evaluations of the metrics that are the most important for the case. Hope that was useful, but that's basically the step-by-step. I suggest taking a decision and just walking through it, and then you'll know how to do the tool when you want to use it in the future. All right, thanks everyone.